So thank you everyone for coming out. I'm glad that we got to talk about robots taking over and putting us all in a zoo this morning. So now let's talk about zombies and what they're going to do to us. So this talk, Fending Off Zombies with OTP, otherwise known as Building Telephony Applications with Twilio and Elixir. So before I jump in, how many people here have actually used Elixir? Okay, so a couple of people. So my name is David Long. I'm the Director of Development and Client Services for Cage Data. We're a managed IT firm from Connecticut in the US. I generally tell people I just live in the forest that is between New York and Boston. So I am a husband and a father. My wife and 2 children are wonderful for letting me come out halfway around the world to give this talk. I'm a missionary in Uganda, Africa, and if you want to tweet at me to praise this talk or complain about it, you can find me on Twitter, GitHub, Keybase @DaveJLong. So the end result of this talk goes a lot better if you go out to zombies.ngrok.io and put in your phone number with the country code. If you don't, it's fine, but you won't get the end result. So I'll leave that there for a second. Okay, so fending off zombies, what are we going to do? The first thing I want to do in this talk is just kind of go a little bit over what is Elixir and what OTP is. And also, if you're not familiar with Twilio, I'll briefly go over what Twilio is. And finally, we're actually going to build an application. So we're kind of going to go from 0 to hero in 50 minutes. So what is Elixir? Elixir, if you're not familiar, is a dynamic functional language that runs on the Erlang virtual machine. Elixir is a fairly new language. I think its first commit was somewhere around 2011. But it builds on the back of Erlang, which is a really powerful programming language that first showed up about 1986. And so when other languages were thinking about things like, how do we be concurrent and use all the processors on a single machine, Erlang had already figured out how do we use multiple machines. They had already figured out distribution while everybody else was thinking about concurrency. So Elixir, using some of that power of Erlang, Elixir is extremely scalable. It's designed to be fault tolerant, where Elixir and Erlang, one of their big calls to fame is their error handling. As I said, it's a functional language. And it's also extremely extensible. I was always afraid of using metaprogramming or building my own DSLs until I came into the Elixir world. So I'm going to take a look at a few examples of some Elixir code just to give you a little bit of an idea of the language and what it looks like. So most Elixir applications are not just a single monolithic process. Most of them are built out of hundreds or thousands, sometimes even millions of Erlang processes. And all those processes are able to communicate through this messaging platform. So for an example here, we start out and we grab the current process as just this instance of self, which comes out of the kernel module. And then we spawn a new process, linking it to the current process that's starting it. And all we're going to do in that new process is send to the current process this message, which is a tuple with message as the first key and must eat brains as the actual message being sent. And then finally, we have a receive block back in our original process, and it pattern matches on the first key of the tuple, creating a variable from the second key, and it just outputs that to the console. So another example of some Elixir code, and this is to show some of its fault tolerance. So Elixir has this module called the supervisor. And what the supervisor does, exactly as the name defines, it supervises other processes. So here we've got a supervisor, and it's going to have 2 children. One of them is another supervisor, the zombie horde, and that's probably just out there spinning up as many zombies as it can. And then it's got a worker, the hunter, and his job is going to be to destroy those processes. And starting up that process tree, very simple. We just call supervisor.startLink with the children and what strategy to use. So the supervisor is going to handle how to restart applications if they fail. Because as perfect as we are, all of our applications will at some point fail. So here we're going to use 1-for-1 as their strategy. And what that means is that if one process fails, so if the worker fails, it's going to create another instance of the worker. The other option is one for all. And what one for all is going to do is that if one process fails, it's going to restart the rest of the supervision tree. There are a couple other strategies, but in general, you'll use one of those two. And then finally, one of my favorite things about Elixir is its idea of pattern matching. So in most languages, you can't do this. So we have 3 functions, shoot, that all have the same signature. They all expect one argument. And it's going to determine when I actually call the function, which function to run that through based on the signature provided by this weapons.get. So the first one, it's going to look and it's going to check for this weapon struct. Same thing with the second one. It's going to grab the uses out into a variable, and then it's going to check for the type. So it's either a rifle or a knife. And then this final function is just a kind of catch-all. So this underscore is accept anything that hasn't been matched so far. And then after we initialize this argument, we can actually check before we get into the function if ammo is greater than 0, which we got out of the struct earlier, and if uses are greater than 0, which we got out of here, then run through one of these functions. So there's a lot of cases where this weapon can get halfway through. It might be a rifle, but it has no ammo left, so you're now a zombie. It might be a knife, but the knife has been broken. You're now a zombie. So that's how Elixir does its pattern matching, and it allows you to create really powerful logic routing in your applications. So to provide an example, this is some object-oriented code, and all it's going to do is it's going to take a title and turn it into a URL slug. So this is written in Ruby. I tried to do it in .NET when I heard that there was a lot of .NET people here, but I can't get this next part to really be easy to write. So we take that title, we convert it to its lowercase form. We use the gsub method in Ruby to replace any non-word character with a space. Then we split the string based on spaces, and finally join it back with a hyphen. And that gives us top 3 reasons to love zombies. So my problem with this is that to figure out where an error happens in here, I have to know what kind of data structure I'm working at the time. So if, for example, it fails on join, I have to remember that join is out of the enum or the array data type. Functional code is different. Functional code, and this is another construct in Elixir called piping. And the idea of piping is that the first, the response from the previous function, so title, for example, becomes the first argument to the next function. So string.downcase expects a string to get passed in. And so that string is going to come from title. It's going to pass the result as the first argument to string.replace, which will get passed to string.split, and finally enum.join. And then we end up with the same result. And so as I said, here I know if it fails on enum.join to look in the enum module to see where it's actually failing there, as opposed to the object-oriented approach, which I have to remember where that is. So finally, the most important thing about Elixir in any programming language is what's the tooling like. So in Elixir, we have Mix, which is just a super powerful build tool. It can do just about anything for us. It'll have tasks for running our application, compiling, running our test suite, or also creating new applications. It's super easy to extend, and I'm going to show you in a little bit how you can actually write your own Mix tasks. And it's also there to manage your dependencies. Those dependencies come from the Hex package manager. It's similar to Ruby Gems, or NPM, or Pipey. And to give you some info about how much Elixir is being used, so there's currently 4,900 packages on Hex, which is just over half of what's on Ruby Gems. There's 500,000 daily downloads and 127 million all-time downloads. So given how new of a language it is and those sorts of metrics, it's pretty impressive. So the next thing we need to know is, what is OTP? So this was a quote that I found that I just thought perfectly describes it. So we know that Erlang's power comes from concurrency, it comes from error handling, an OTP framework really is the third half of the greatness of Erlang. So OTP are just simply a set of modules that we can use to manage application state, application processes, as well as asynchronous tasks that need to run. And one of the simplest pieces of that is the agent. So agents are just simple state managers. And here's an example of one here. So let's create this weapon. And a weapon is going to have some state because we have to know how many, if it's a gun, it has to have ammunition in it. If it's a knife, it can only kill so many zombies before it'll break, right? This is, in any game you might develop, this is a construct you'll need to have. So to create an agent, all you do is you have use agent in your module. And what use does is it goes into the agent module, and it's going to call a macro there called underscore using. And that macro can define different pieces. So the primary thing that it does is it defines this child spec method that we'll use later on. So then we have to define our API, and our agent is just going to store a simple number of how many uses this weapon still has. And we do that by simply calling agent.update with what module it's going to update, or what agent it's going to update. We're just using the current module as the agent. And then this is a little helper for creating a function that takes whatever arguments passed into it and subtracting 1 to it. And what gets passed in, that &1, is the current state. And then we also have our API method for reloading our weapon. So if it's a gun, for example, which simply sets the state back to the initial value. So to start up our agent, what we're going to need is this start link function. And start link determines how to actually start up the agent, and specifically what's the initial state. So our initial state comes from this module variable 10. So it's going to be, you can use it 10 times. So as I talked about, we now have, and this, I didn't update it for this talk mistakenly. So we've got our agent, which was originally task server, it's now weapon. But how do we actually start this with the application? Well, that's where this supervisor comes in. So let's create one. So we've got an application, Walking Dead. And the easiest way to create a new supervisor is actually just do it when you're creating the application itself. So again, we can use mix when we create a new application, saying mix new, whatever the name of it is, and tell --soup to create a supervisor along with it. And that creates this Walking Dead.application module using the application module, which is a supervisor. And then we have to specify the start function. And inside that start, we create all of our children, and that's that child spec that comes from agent again. And you can use nil to customize, for example, the name of the agent that's starting up. So there's the agent. And then again, just like before with the supervisor, we've got what strategy to use. And again, we're using 1 for 1. And what name to give our agent. So again, this actually should have been Walking Dead.supervisor. And that's the name to use when you need to interact with that supervisor from other spots of the application. And then there we go, supervisor.startLink. And most of these OTP modules have both a start and a startLink function. What those mean is startLink is link it to the current process, whereas start is an unlinked function or an unlinked supervisor. It'll just keep running until the Erlang VM is shut down. So now we have to run our application. One of the things that happened when we used mix new is it set up this function in our mix config file. And Elixir by default will always start up this logger for you. And we also tell it that we're going to run walkingdead.application. And then to run it, we just use mix run, or we can run it inside of a REPL with iex-s mix run. All right, so the last thing before we can actually look at some real code is what is Twilio? If you're not familiar, Twilio is an API for phone and SMS. They also provide TaskRouter, which is APIs for communication workflows. They have a two-factor authentication platform that they acquired called Authy, and you can pretty much think of them as your APIs for communication of any kind. Okay, now the fun part. We got through all of that. So let's build something. So we have to start with user stories, right? We're going to start a nice new project. So our user story, as Zoe Zombie, I want to eat brains. as President Paul, I want to alert my citizens about Zoe Zombie. And as Citizen Stan, I want to know when zombies are coming. So let's start this new application, mix new zombie alerter -- soup. And let me switch over. Okay. So this is the new application that got created with mix new -- soup. And I've added a few things just so we don't have to wait for the internet mostly. So we have our mix file, and new application creates this mix.exs. So you'll see two file extensions with any Elixir code. There's exs, which is Elixir script, and there's ex, which is just Elixir. The difference is that exs is not compiled. So anything in Elixir will eventually become bytecode that runs against the Erlang VM, the Beam virtual machine. Elixir script is compiled at runtime. Any other Elixir code is compiled ahead of time. So our mix file is non-compiled. And we set up a couple of variables here for what the app name is, what version, things like what version of Elixir we need to run. We have an application function here that defines that application we saw before. And then we have all of our dependencies, and these come out of the Hex package manager. And just to run through them really quick for you, Cowboy and Plug, they go together. Those are HTTP, it's an HTTP library. So Cowboy is an actual HTTP server. Plug is a set of modules for interacting with it. Twilio and Twiml are just Twilio libraries that we'll look at in a little bit. Poison is my JSON encoder that I'll need. And Remix is just a handy dependency that I include with projects that'll handle reloading code in development. Okay, so the other thing here is that there's a front end of the application that if you went to that zombies.ngrok.io, you saw it. And that's just simply Webpack running a Vue application. So you can see there I've got Webpack and a package.json for Yarn to pick up. And so the last thing we'll look at is the supervisor, and this is everything. This was entirely created just with mix new. You get a lot of this for you. Okay, so let me just switch to the next step. Whoops. Okay, so as I said, extending mix with your own tasks is actually pretty simple. So we have two processes that we need to run. We have our router, which is going to run as an Elixir application. And then we also have this Webpack front end that we need to run as well. So to create that mix task is as simple as adding here, and let me zoom in a little bit more, adding in lib/mix/tasks zombie.server. And so if I close the terminal there, you can see it's all just Elixir code, and the only thing required by a mix task is this def run. So Elixir is going to figure out what the task name is based on the file name. So I used zombie.server as opposed to zombie_server like most other modules are defined as. And then I just simply say that I'm going to use mix task just like I was using agent before. And I'm actually going to need the logger for this, so requiring the logger just ensures that it's running for me. And then my run definition, I say if we need to watch the assets, then spawn this start watcher function. And start watcher simply runs the system command after some validation. And so you might have seen that I get a lot of this IntelliSense data from, for example, zombiealerter.watchAssets. One of the really powerful things about Elixir, if I go into the definition of that, is Elixir treats documentation as a first-class citizen. So here I have this this watch assets function, and I specify, at doc should asset watcher run. And when Elixir compiles it, it compiles that documentation into the application for you. So in my zombie server, I can just simply look at that with the IntelliSense. And that's part of Elixir. That's not part of VS Code. So you might have seen here in my zombie alerter.watch assets, I'm using application.getend to actually look in the environment for should the asset watcher be running. So this is something where on production, for example, you're not going to want this Webpack running all the time. You're going to compile the JavaScript, upload it to some CDN, and then you're going to move on. So we have application environment, and because Elixir is a compiled language, you need a way to have a different environment compiling versus what you actually run this code in. So if I look in config, I've got these 4 configuration files: config, dev, prod, and test. And you notice these are all EXS, so they're not being compiled with the rest of the application. And config, all I'm doing is importing mix.env. So for development, it's going to import the dev config file. And I'm using, again, this is where mix comes in, using mix to configure it. And I've got my zombie alerter watch assets true. And I can access all that data anywhere in the application with that application.getend. So if we look at the next stage here, and I figured this was a lot better than actually building an application from stage. So the next thing I want to look at is this front end that you guys saw before. And it's a view-based application. So I've got my index file, then inside of components, I have app.view, which is just an HTML form and a view front end to take the result and push it to the server through Ajax. So how was that server actually running? Well, let's take a look at the router. So I've added this in my application file. I've added two new children to the application. There's plug.adapters.cowboy. And what that is that's part of the plug library. It'll create a cowboy adapter. So cowboy is the HTTP server running on HTTP. So you could use plug to do other transport protocols, but I'm using HTTP with the zombie alerter.router module, passing in what IP it should listen on and what port it should listen on. And port, I'm just pulling it again from the application environment. And I'll look at subscriptions.childspec in a second. So here's the router. And a lot of people, when they think about Elixir, they think about the Phoenix framework. I have almost never had to use the Phoenix framework. If you're not familiar, it's been attributed to being the Ruby on Rails of Elixir. I'll talk later about why that's completely false. I use plug for the most part, and I use specifically the plug router. So plug is just a set of modules for working with HTTP, working with web applications. The plug router makes it really simple to write up this route DSL. So I have my document root, and this gets mapped to a private function, or it gets converted to a private function by plug's DSL. But my document root, which is just using the EEX module to compile this HTML file. And that HTML file is basically HTML with this little bit of Elixir tied into it. But if I go back to the router, and then finally it sends the response back. Connection 200 body. Connection is the connection that came in, and it gets defined when the get route gets converted into a private function. But where plug is really powerful, rather than just building these routes, is the reason that it's called plug is it's extremely pluggable. So what's actually happening here is, I've used the plug router, and then I've got all of these different calls to plug's function. So I've got plug.logger, plug into match, plug into the parsers, the static, and dispatch. So what these actually do is it routes that connection through all of these other modules and functions before finally handing it down to, if it needs to hand it to get the document root, to post subscribe. It's going to run through all of these first. And what these do is they just take different actions on the request. So for example, plug.logger very simply logs that a request happened. Plug match is the actual plug that goes in and matches all of these routes. Plug.parsers handles parsing any request data. So here I'm parsing out the URL encoded data. Plug.static is going to serve up static assets for me. If I make a request to /assets, it's going to find that file in priv static. And plug dispatch finally dispatches that response back to the connection. So I also have this post to subscribe, and that's what we're sending the phone numbers to. And that takes the phone number. It takes out any non-numeric characters, and it passes it to subscriptions.subscribe. And so subscriptions.describe, just like we saw before, is an agent. Instead of using a integer as state, I'm using a map set. And map sets are just a basic set implementation in Elixir. So if you're not familiar with sets, they are unordered lists that cannot have any repeating values in them. So I don't have, you can submit your phone number 50 times, it's still only going to be in this map set once. And so after subscribe, I've got the subscribe method, or subscribe function, that grabs my agent and it updates it with the new map set. And then I've got a get all function that simply grabs the set and turns it into returns it. So I'm doing one thing different here than I previously did when I showed you guys the agent. The difference here is that rather than just using the module as the name of the agent, I'm using my own name if I want to. And the reason for this is so that I can test the agent later. So in each one of these, I have to figure out what agent I'm using, if it's been passed in, or if I need to use the module. And then I grab the agent from there. And so the reason I said that I would do this is so that I can test my subscriptions. So this is what Elixir testing looks like. The framework for testing is called XUnit, and it looks very similar to most unit testing frameworks that I've seen in the past. So to test that I can store a number in the subscriptions, I have to start up an agent, and I'm starting it up with its own name so that it is only for this test, and then it can go away. I subscribe a number to it, and then I assert that that number exists. And if I run that test with mix, compiled, and then it ran it for me. All right, so now let's jump to the next step here. So we can now take in information. We can, we collect the phone numbers. So we need to start doing something with that soon. And you saw that I'm using the Twilio library before when I was looking at the dependencies. That's going to let me interact with the Twilio API. And I'm also using the XTWML library to create those TWML responses that Twilio wants. The thing is that I need to store secret data at this point. I need to store data that I don't want in code form. I want it not leaking into the repository or anything like that. So I don't want to put it in, dev.exs. I don't want to put it in any of those. So I have always used this trick where I set a config file, config variable, and I use this tuple of system and then what system variable to look in. And the reason for this, as I said before, Elixir is a compiled language. So I don't want to just grab the variable at this point and pass it in, because now that's getting compiled into my application. Instead, I want to grab the system variable at runtime. So how does this actually work? Well, it's only about 15 lines of code or so. So I have this Getend function that I've added to my zombie alerter module. And that simply grabs the variable from mix, and it sends it to Getend. It calls itself. And that has two implementations that it could go through at that point. You can either go through Getend accepting this tuple of system and some variable, or it can go to this, which is any other value, respond with OK in that value. And then in this Getend, it's going to look in the system. If it returns nil, it responds with an error. If it returns anything else, it responds with that value. And this way I can grab my environment variables at runtime as opposed to compile time. And this is one of the other parts of Elixir where as I said before, documentation is a first-class citizen. So here's the documentation for my Getend function. And if I hover over it, I get the nice output. And even more so, if I run my tests now, zombie alerter, and actually, let me trace it so you can see it a little bit better, what's happening. So it actually ran test docs. What happens is this code that it's running here becomes the test for the application itself. So your documentation not only is now the documentation of the application, it's also the test interface. And if I open up that test file, all I do is I call doc test zombie alerter. So your examples can also test the application, and everything can happen within that one module, as opposed to having to break out everything else. And now you can have, writing out the examples for an open source library becomes the tests that are in the documentation. Okay, so let's go to step 5. Okay, so now we actually are going to start using requests from Twilio. So I've added another route here, /API to API. What's going to happen is any request to the /API route now gets forwarded to this API module. And this last route at the bottom, match _, that's sort of, again, the catch-all route. If anything makes it down that far, regardless of what kind of request it is, whether it's get, post, patch, or delete, it's just going to send a 404. So if I look in the API here, I have not defined any of the routes yet, but I have lined up all of the plugs that I'm going to want to use. So I've got plug.logger again, match, and then I've got this Twilio auth and Senderoff before dispatching, as well as XML response. So I'm going to work from bottom to top. XML response is a very simple plug. All it is this function at the bottom, which ensures that we're always returning XML as Twilio expects. That's as simple as it is to write your own extensions on plug, and that's automatically going to get added to each request. Twilio auth and Senderoff are slightly more complicated, so they're in separate modules. But to write your own plug, all you actually need is an init function, which accepts one argument, and a call function that accepts 2. The init function takes in options when I specify the plug. So if you saw, I'm passing in the Twilio auth token. And the call function takes in those options as well as the connection object. And if you're not familiar with Twilio, the way that they sign the requests is they put this Twilio signature header in, and they take the URL, append all the parameters, and hash it with SHA-1. So I do the same thing in reverse here. And I can either halt the request with 401 at that point, because somebody is trying to hit this that's not Twilio, or I can just pass the connection back, and it's going to move on to the next plug. So the next plug, as we saw, was the Senderoff. Same basic idea, is I have this options, and the options, one of the parameters is the senders, who's allowed to send to the application. Because if we're sending alerts that there's a zombie invasion, we don't want just anyone to say that there's a zombie invasion. Not if we're texting everyone in the world. So again, it's the same idea of you either get this 200 with a block message back that you are not authorized to send an alert, which is going to result in a text message coming back from Twilio, or it passes the connection back out. You can do other things here. I've used it for, if I'm writing an actual authentication library, I'll append the current user to the connection, or other pieces like that. You can also look at options that come from the request itself. So I can set private options on different routes. So maybe that post to subscribe is going to have some private options to it that I can append to for the plug. So if we go back here to our API, so it's going to go through all those, and if it gets down to XML response and down to dispatch, now it's going to go into our router, which we haven't defined anything yet, so let's go ahead and do that. Okay, so we now have a route. So I've created this post/SMS, which is what Twilio posts to. And then we've gone through the Twilio auth, we've gone through the Senderoff. So if it makes it this far, all it's going to do is create this new message, pulling some options that Twilio has provided, and it's going to pass that to sender.send before sending the response. And the response is very simple Twilio code so that whoever's sending the alert gets a message saying message received. And if we look at sender, sender again is a very small module. All it does is it takes our subscriptions, gets all of our subscriptions, stop IntelliSensing, gets all of our subscriptions and it goes through each one of them, spinning up a new task to send out that text message. So let me see if this will actually work. It worked once so far today. So let me see. So if you really want to see it and now your interest is piqued, it's zombies.ngrok.io. And there's a few people that subscribed. So I'm an authorized sender. None of you can actually send to this because that'll get really bad. So let me do this. There, we got at least one message that went through. So who all got the message? Awesome. So now we have built a zombie alert application. And so now we go back into our slides. So as I said, the other thing we could have done is used Phoenix to build this. So as I said, Phoenix gets attributed as the Rails of Elixir. And it's not that. I've been doing Ruby for almost 10 years. I love the language. But Rails is a monolithic monster when you really get into it. Phoenix is not like that. Phoenix is entirely pick and choose what you want. If you want static assets compiled with the application, take it. If not, you simply don't include that. If you only want a router, you can use that from Phoenix. You can use just the controllers. You don't have to use the modeling layer. So Phoenix is really powerful. But I find that most things I want to do are simple enough to do in plug. I mean, we wrote that application using Twilio in 15 minutes with about 200 lines of code, maybe. Most of that I did not write myself. So how is this relevant? Why would we ever need to build an application that can alert about zombies? So this was a little bit difficult to figure out, but then before I left here, Hurricane Irma hit Florida. And so one thing that is true all around the world is that when massive storms hit, when emergencies happen, the first thing that'll fail for technology is data connection. So our mobile internet, our home TV, those things will be the first to fail for technology. Texting and phone calls are the most stable because they've been around the longest and there's the most infrastructure dedicated to it. So when you have something like this where you have a massive hurricane that's about to take out a quarter of the US, our data connections dropped. Throughout Florida, throughout Puerto Rico, data was down, but SMS and voice still worked. The other thing, as I said, I'm a missionary in Uganda, and one of the things that I've had to deal with is I don't work in conflict zones, but I work with children who come from that. And one of the hardest things that you hear about is people just not knowing that they're about to be attacked. So there's been a lot of work over the years to build systems where it's kind of an early warning system for guerrilla fighters attacking villages or kidnappings to happen, where as soon as one village gets hit, every other village in the path can get that notification. And again, SMS and voice are the most stable when you're talking about extremely rural African nations. Another thing that's been plaguing the US and I think the rest of the world lately is protests. Protests against unfair government and, frankly, bullshit like this. So this recently was happening in Charlottesville in the US, where white supremacists, Nazis were out in full force protesting. And one of the things that's really powerful for these sorts of early warning systems is we can get the word out to other people who are against this stuff. We can get it out as fast as we want because it's all based on SMS. You're going to receive that message. You don't have to go and check Twitter anymore for it. It comes to you, and now we can get out against these protests before they take over the streets. So there's a few minutes left if anybody has questions. Okay, great. Well, if you're interested in the slides or the code, it's all up on GitHub, davejlong/zombies. And thank you very much for coming out. I know this was really quick and a lot of information to grasp. So thank you.